Hi there, and welcome to Curious About Innovation from the Glasgow Science Centre. My name is Katie, and I usually work in the planetarium here at the Glasgow Science Centre. But today I'm going to be showing you a video from AAC Clyde Space about Scottish innovation in the space sector. And then we're going to be able to talk to the people in the video, Pam and Derek from the company. So to get us started, let's have a look at that video.
So, hi everyone, I'm Pam Anderson, and today Derek Bennett and I are from AAC Clyde Space, and we're going to talk to you a little bit about the space industry in Scotland, an introduction to AAC Clyde Space and some of the cool exciting projects that we're involved with, and some of the reasons that we go into space and some of the really cool applications that we can get from satellites and space data. So the first question we've got is why do we go into space at all? So we see these pictures of rocket launches, we see things landing on other planets, and it's all very cool, but why on Earth do we actually want to go to space in the first place? So we see this picture of Earth. It's one that we're all familiar with, the view of Earth from space, sometimes referred to as the pale blue dot. It's what we know Earth to look like from space. In actual fact, Earth from space looks a little bit more like this picture here. So actually we have around 5,000 satellites orbiting the Earth at any time. So you've got these satellites that are really close to the Earth that you can see here, these kind of clusters around the surface. Those are satellites in what we call low Earth orbit. So typically a few hundred kilometers off of the surface of the Earth. You've then got these geostationary satellites around this big ring around the Earth's equator here. They're about 36,000 kilometres from Earth. And all of these satellites are up in space doing lots of different jobs and giving us some really important services from space. So what size are these satellites? You see them as just tiny dots on that previous image, but actually there's a huge variety of sizes of satellites that are up in space orbiting Earth. So all the way from the very, very large satellites. ENVISAT was a European Space Agency satellite that you can see here. You can see the people just in this image for scale. So a massive satellite about the size of a double-decker bus. So about 8,000 kilograms in mass. That kind of scales down. Then we've got Terra as an example here, about half a ton spacecraft, about the size of a large elephant. And we've got satellites like Jason, which is about 500 kilograms. You can see the grand piano there for kind of scale of reference, and all the way down to a specific type of small satellite, which are known as CubeSats, about 10 kilograms. So these are something that you can quite easily hold within your hands, about the size of a kind of shoebox or a large loaf of bread. And actually then we can continue to scale down into what are known as pocket cubes, so something really small that you can easily fit in one hand. So a massive range of scale of satellite, and that's really because they're up there to do lots of different jobs. So it depends what instrumentation you want to put on the satellite determines how big that satellite is going to be. So why do we go into space? Well, we go there first of all to understand better the Earth. So we've seen this image previously. We kind of agreed that's how Earth normally looks from space. Actually, Earth can also look like all of these kind of funny coloured images here. So these aren't just pictures that are made up, but give us some really important information about Earth from space. So the top kind of bumpy, colourful image you can see there is actually a gravity map. So gravity is not constant across the surface of Earth, but actually varies, and the colours will tell you how it varies across Earth. We've got really important measurements of essential climate variables. So things like sea surface temperature, you can see that middle colourful image there where the oceans are characterised by different colours to determine how hot or cold they are. Got things like wind vectors, which are really important for feeding into climate and weather models. Crustal dynamics, that kind of funny bumpy brown Earth image there, can help us to look at predicting things like earthquakes and volcanoes. And then things like water vapour in the atmosphere, so measuring through the atmosphere can help us to, again, with climate and weather models. So we get some really, really valuable information about the Earth by looking back down from space. We get a really unique view of Earth from space where we can see a much larger area than we would be able to from, say, an aircraft or a UAV, or even taking kind of in situ measurements from the ground. One other really important element of going into space is to make sure we don't get lost. So from PNT, or position, navigation and timing from space, we can get some really important applications again that we use kind of in everyday life. So the obvious one is what you would call sat nav. So you've maybe been in a car where you've been told turn left, turn right, making sure you don't get lost. All of that mapping information is coming from satellites orbiting the Earth. Even for things like tracking vessels in the ocean, so making sure that all our deliveries are getting to where they need to go around the globe, satellites are really important for that. Animal tracking, something that we probably don't think of being in any way related to space. So you can have these, kind of almost animal Fitbits where they're tracking habitats and movement of animals, making sure that we don't harm animals when we're monitoring because we're doing it remotely, and being able to track things like habitats and welfare, really important. And then things like banking, so finance use really precise timing information from space to monitor things like banking transactions. And if we didn't have this satellite technology, actually a lot of our economy would instantly collapse. So it's really, really vital to the way that we operate in the world today.
Hi there, my name is Bennet. Okay, so I'm going to talk a little bit about Scotland and space. Okay, so you might not know this, but the space sector in Scotland is one of the country's fastest growing sectors, with over 130 companies and over 7,500 people innovating in this exciting sector. The Scottish Government has ambitious plans to grow the sector to 4 billion by 2030. So the question is, how do you actually do that? Well, there are people innovating in research and development at many world-leading Scottish universities, as well as the actual companies themselves. In terms of manufacturing, Scotland is building more satellites than anywhere else outside of California. And next year, the aim is to launch small satellites from one of the spaceports currently in development in Surland and in Shetland. Finally, we have a wealth of experience of companies actually using that data that is delivered by satellites to solve global challenges, with the ultimate aim of improving life on Earth. Now, the company that Pam and I work for is Clyde Space, like we've mentioned. It was founded in 2005 and is now a multinational company with offices in Sweden, in Glasgow in Scotland, in Holland, and also America. We specialise in the manufacture of satellite bits, such as batteries, solar panels, and many more. And then we also design missions and manufacture, launch, and operate the small satellites. And that could be for organisations like the government, so for example, the UK Space Agency or NASA, to commercial companies, and finally to educational organisations like universities. Now, the satellites that we manufacture are known as CubeSats. The smallest one is a 1U CubeSat that is only 10 centimetre cube, so it's small enough to fit in your hand. Building on this 1U CubeSat, we then make slightly bigger ones. So for example, we can have a 3U CubeSat, which is simply 3 1U CubeSat blocks stacked together. And as you can imagine, and you can see in this slide, that can grow to a 6U or even a 12U platform. Another part of what we do is we develop subsystems for other small satellites. And this slide here gives you an overview of some of those missions. A very exciting one for us just now is that we are developing a subsystem that's going to be going to the moon, hopefully later this year. Now, once we send these satellites into space, there's a variety of different applications that they can be used for, like Pam's discussed. As an example, we designed and built a 3U CubeSat that was used to gather information on the temperature and humidity of different places around Earth. And this picture here actually shows that satellite been deployed from the International Space Station in 2019. So I think it's a pretty cool image to think of a satellite that's been built in Glasgow and then set up to the International Space Station, and then you can actually see it getting deployed. Okay, so what does the future look like for AAC Clyde Space? Well, in the future, we envisage constellations of hundreds of these CubeSats being launched into orbit, potentially from spaceports in Scotland, delivering a wide variety of services that will ultimately help improve life on Earth.
So we've told you a little bit about what the space sector looks like in Scotland, some of the cool things that we're doing at AAC Clyde Space. What does that mean for you? There are a wealth of possible career opportunities, both in Scotland and in the UK, to be involved in the space sector. If space is not your thing, then actually we really need people to be studying subjects in science, technology, engineering and maths, or STEM subjects. So over 60% of all new jobs created are going to be in STEM related subjects. And actually what that means is that we're going to have a real gap in the number of jobs that we require in STEM subjects versus the number of people that we have to fulfill those. So we really need people to study these subjects and to take up careers in STEM to make sure that we fill that gap and we're continuing to grow these really important sectors. If space is your thing, there's a few resources I would encourage you to take a look at to find out a bit more about what's going on in the space sector in Scotland and in the UK. So things like the Space Careers website has this really nice infographic that you can see here, where it lists a whole range of different jobs in the space sector. These are real people's jobs. You can hover over them and see the types of things that people in the UK are working on. So it's not just about being an astronaut, but there are so many different jobs in the space sector that are available to you, all the way down to, to things like insurance and law, things that you would never associate with the space sector. Space Careers has some really good videos as well, again, to just highlight some of the different opportunities that are available. And I think one of the really excellent resources that are available was created by WISE and their People Like Me campaign, where you can go on, you can do a survey, it will tell you about your personality type, and then it will match you up with people in the space sector who have the same personality profile as you, and it will tell you the types of careers that they're doing. And that means that you can see the types of opportunities that might be available to you depending on your skills and your interests. And then finally, a bit later, probably when you're maybe at college or university, there's an opportunity called SPIN or SPINternships, and that's the Space Placements in Industry. And that has hosted placements from lots of different companies all over the industry, where you can go in and complete a summer placement as part of your university career. So lots of different resources available. That's just a few of them. I really would encourage you to take a look, and overall would really encourage you to pursue a career in the space industry in the UK, because we really need young, interested, enthusiastic people. There's so many opportunities to fill. And I'm sure one day we'd be absolutely delighted to see you at AAC Clyde Space.
Wow, that was a really interesting video from AAC Clyde Space. And now we are lucky enough to be hosting Pam and Derek here virtually at the Glasgow Science Centre. Hello, guys. How are you today?
Good,
Hello,
thanks.
Fantastic. That was a really, really informative video. So thank you so much for filming it for us. We got a few questions from the schools that are viewing today, as well as some videos, some questions coming on from YouTube as well. So we're just going to bowl straight into them if you're okay with that.
Yeah, go for it.
Fantastic. So the first one is from Hindland Secondary School, and they ask, how long does it take to make a satellite?
Okay, I can take this one. So yeah, so it really depends on the type of satellite you're making and how big it's going to be. So the type of satellites that we build at AAC Clyde Space are nanosatellites, and like we said in the presentation, they're the size of a kind of shoebox. and they'll typically take around about 12 months to build. And that goes all the way from the mission analysis and design up to the actual manufacture of the satellite, and then all the testing that's involved to make sure that satellite can work in space, which is obviously very important before you send it up. For the bigger satellites, the ones in geostationary orbit, they could take up to, for example, 10 years to build. So over a long period of time. And that's one of the big advantages of the type of satellites that we're building at AAC Clyde Space, and that we can build them very quickly and get them up to space in a very short time. So yeah, hopefully that answers.
I love that 10 years is fast, and for space it is really fast. We've got the James Webb Telescope going up, I think, later this year, and it's been in development for 20 years. So even though 10 years does sound like a long time, it's actually quite quick when it comes to the space sector. Thank you so much, Derek. So we've got another question coming in here, and this is from Paisley Grammar, and they're asking, how many satellites are currently in orbit?
Yes, so I can take that one. So we mentioned about 5,000 satellites in the presentation. I actually think that number is a little bit out of date, and it's probably closer to around 6,000 satellites in orbit. Some of those are operational and some of those aren't. So probably around 40% of those are currently operational. And the other 60% of those are satellites that have come to the end of their life and are still orbiting around the Earth. So yeah, huge number of satellites up there. And that could potentially create an issue for space debris in future. So there's lots of people looking at ways to mitigate space debris, and there are rules that you have to comply with in terms of the number of years that you can stay in orbit around Earth, so that we don't get kind of overcrowding and congestion up there.
Yeah, fantastic. I know space junk is a problem, and I think we do actually have a question from one of the schools about space junk. Yeah, we do indeed. It's from Hindland. Again, is there currently any way to remove space junk?
Okay, I can take this one, Pam. So yeah, there's lots of projects going on looking at different ways in which we can remove space junk. One of the missions going on just now is actually using a satellite that will capture one of the satellites that wants to be taken down, and then it'll push it down into a lower orbit, and eventually that will burn up in the atmosphere. There are other ideas. For example, when your satellite comes towards your end of your life, you could deploy a solar sail. So as you're orbiting Earth, that solar sail will increase the drag on the satellite, and that will lower its orbit, and eventually it will come down into the atmosphere and burn up and be destroyed. So there's a lot of work going on in this, and it's a really active area at the moment. So yeah. Fantastic.
It's good to know that we're looking at ways to solve that problem, especially if we continue to launch all of these satellites from AAC Clyde Space as well.
Yeah.
Okay, we've got another question coming up as well. So personally, this one's for myself, I didn't realize that satellites helped so much with banking in the economy. Are you able to explain a little bit more about that?
Yeah, sure, I can take this one. So banking relies on basically really precise position and timing information. So banking transactions will have to have a time tag on them that needs to be, really kind of millisecond precision. And they all must agree, all banking transactions must agree on kind of a standardized time. And essentially that comes from your satellites that are in what we call a global navigation satellite system. So they provide precision navigation and timing information from space. So that precise timing information helps us to time tag transactions when we withdraw money from ATMs, when we transfer money around the world. There are millions of banking transactions that go on every second, and those rely on really precise timing information that we get from satellites, as well as that location information. So to help to kind of geotag information to help prevent fraud and make sure that we can track where transactions are taking place. It's also really important for the stock market as well. So they rely on again, that really precise navigation and timing information. And you really, to lose that information for even a second or a fraction of a second can be really detrimental and cost millions in those transactions.
So the space sector really does cover so much more than just space.
Absolutely.
Oh, yeah. Yeah,
Fantastic. Another question coming in. And this is, what is the difference in capability between a smaller satellite versus a bigger satellite?
Yeah, I can pick up that one. That's a really interesting question, actually, because I think historically there maybe has been quite a big difference in capability of these small nano satellites versus the large satellites. What we're seeing now with miniaturization of electronics, so if you're familiar with Moore's law, where we're seeing increasing capability for smaller scale of electronics, actually we're seeing the smaller satellites become much more capable than they previously were. So, for example, one of our missions was Seahawk that we worked on in collaboration with NASA, with the University of North Carolina, Wilmington, with a company called Clyde in the US as well, who developed the instrument. And really, the really amazing thing about the Seahawk spacecraft was that we could get comparable data to a much larger satellite, so the SeaWIFS instrument, for about 100 times smaller mass size of satellite. So really, we're then able to recreate data that's been produced by a much larger, much more expensive spacecraft that takes a lot longer time to develop for something that's a fraction of the size and cost. So really impressive things that are happening on kind of miniaturization of electronics. Of course, there's always still going to be some limitations to that. So, rules of physics will dictate performance of certain instruments, and so your larger spacecraft are always going to be more capable than some of the smaller satellites, but that's a kind of trade-off in the number of satellites you can launch. So, for example, for the cost of one large satellite, you can maybe launch tens or hundreds of small satellites that mean you can get much greater coverage over the surface of the Earth. That means you can get data more frequently, you can launch them more quickly, as Derek was talking about, and again, you're kind of splitting the cost and risk over multiple satellites. So it's a bit of a trade to be made, and that's something we're doing all the time at AEC Clyde Space, is that trade between performance and kind of the commercial aspects, the cost and the risk.
Fantastic. Thanks so much for that. Next up, we've got a question from Paisley Grammar School. And what is the cost of each launch in terms of, if you can, kilograms per pound or pound per kilogram?
Yeah, so I can pick that one up as well. So it varies greatly. Not a brilliant answer, but there's a huge variation. And I think just now what we're seeing is a lot of technology development on the launcher side of things that's really looking to drive down the cost of launch significantly over the coming years. So where we're at just now, probably in the US market, is somewhere maybe between $1,000 and $3,000 per kilogram. NASA and others in the US have real ambitious targets to take that down to kind of tens of dollars per kilogram over the coming kind of decade or so. So there's really a real drive towards lowering the cost of launch. We see that variation depending on what type of launcher you go for. So whether you're going for a big, really big rocket, or whether now we're seeing a lot of development, particularly in Scotland, around smaller launch vehicles that can accommodate the types of small satellites we build at AEC Clyde Space. So there's lots of ambitions kind of in the US and in Europe as well to kind of drive down the cost of launch.
Fantastic. That's amazing, the cost of that. I had no idea that they were so high, but it's great that we're working on lowering that as well. Right, so we've got another school question from Heinland Secondary School. How do you launch satellites into space?
So we typically put these small satellites into CubeSat deployers, so kind of boxes that can accommodate a number of CubeSats, and those are integrated with the launch vehicle, often alongside a much larger satellite, which would be the primary payload on board the launcher. So we what's called piggyback on some of the larger satellite launches. And essentially then your rocket launches. We've launched from places all over the world, from the US, from Russia, from Europe. And once you're up in orbit, then the CubeSats are all deployed out of this deployer. So they're basically just kind of fired out the end, as the picture that Derek showed of it being launched off of the International Space Station. You saw that kind of box there. So that's the CubeSat deployer. And essentially then, yeah, you're just put into orbit straight from there. But lots of launch options now that previously didn't exist. So there's been a lot of development on the launcher front, and hopefully soon we will see also launch from Scotland.
I loved that photo actually of the CubeSat being launched from the International Space Station. What an amazing photo that is.
Yeah,
I was
cool.
blown away. Yeah, absolutely. We've got another question, I think, coming in. And this kind of relates as well, I think, to the last one, is why is Scotland such a good location to host spaceports?
Yes, I can pick this one up as well. So Scotland in general is a really good place for launch. So essentially our position globally means that we are ideally placed to launch satellites into polar orbits, or what we term sun-synchronous orbits. So sun-synchronous orbits are low Earth orbit that essentially mean a satellite will pass over the same point on the Earth at the same mean local solar time every day. So that means that the illumination conditions for that satellite will always remain constant. Essentially, the orbit precesses the Earth at the same rate as the sun. So you're always in the same illumination conditions. And that's really valuable for Earth observation missions. You can do a lot of really interesting things by having that constant illumination. So Scotland is ideally placed for us to get into these sun-synchronous orbits. We also want, when you launch, you want to make sure that you're not launching over inhabited areas. So you want a fairly remote location to launch from, and the potential launch sites in Sutherland and Shetland and in other places give us that. So with some maneuver, you can essentially make sure that you're not over land when you're launching. So it's really our kind of geography that makes us a good place for launch.
And you mentioned two different spaceports there, Sunderland and Shetland. Are those where they're making them here in the UK, in Scotland?
Yes, so there's lots of developments in Sutherland and in Shetland, and there are a few other potential sites as well as in the UK. So Cornwall and Prestwick and others. There's lots of activity ongoing in this area just now. So yeah, we're really excited to see what happens in future and where we can launch from.
Yeah, absolutely. I'm really excited to possibly see a launch from Scotland into space. I mean, how exciting would that be?
Yeah, okay.
Absolutely. Okay, so we've got another question coming, and this one is from YouTube. It's from Mohammed Karam. Sorry if I've said your name wrong. They ask, are there any being worked on space elevators in the world? Well, it's a different one. Does anybody want to answer that?
Yeah, different one.
You're testing us here. It's something I know very little about.
Yeah, I'm kind of the same as well. I'm aware of a lot of the universities, certain departments, like in kind of advanced space concepts, are definitely looking at space elevators as an idea, but it's very much at the kind of fundamental research kind of stage. So we've got a scale in research known as the technology readiness level. So that tells you how ready that technology is to be commercialized. So it goes all the way from 1, where it's like a fundamental idea that you've got, all the way to 9, I think it is the highest. And that's when you can actually go and sell that product. So all the ideas and space elevators and things like that are way down at the bottom. But I think as time progresses, that's when those ideas propagate through that technology readiness level and eventually become a commercial opportunity. So yeah, space elevators could be something for the future. It's definitely interesting.
Imagine that. I have been lucky enough to go up one of the tallest buildings in the world, and the view from there was amazing. I can't even imagine what it would be like if you were able to just take an elevator up to space. So we've got another question coming up here. So who is allowed to send satellites up to space? Could I send one?
Essentially, historically, space has been kind of the domain of the large space agencies, so people like NASA and ESA in Europe. And now really that that is changing, and that's thanks a lot to small satellite technology and what we call the new space revolution. And essentially, that means that space is accessible to many more participants, so to commercial companies, even to universities to develop their own primarily CubeSats and small satellites. So it's definitely becoming increasingly popular. There's a number of people now who work and operate in the space sector who historically wouldn't have had that opportunity. There are still rules that you must comply with in order to send something up into space. So in the UK, we have regulation from people like the UK Space Agency and from Ofcom and from the Civil Aviation Authority, who regulate and who provide licenses. So you need things like launch and operators licenses. You must file for frequencies from Ofcom in terms of how you're going to communicate with your satellite and what frequency. So there's really stringent regulation around who can actually operate in space, and you have to comply with a lot of rules before you can send something up there.
Yeah.
Wow. Thank you so much. That's really, really fascinating. And another question, and I'm really interested in this one as well. What is the oldest working satellite still in orbit?
I have no idea.
Yeah, no, I don't either. That's a great question.
A really good question, but yeah.
Perhaps
sure.
we can have a look into it and then answer the questions and feed them onto our YouTube channel, or we can answer the questions later for the schools if we can have a bit of time to look into that.
Yeah.
We've kind of touched on this next question a little bit, but if you could go into a bit more detail about what happens to a satellite when it comes to the end of its life.
Yeah, because I can answer this one, Katie. So yeah, so when a satellite comes to its end of its life, it'll continue to orbit the Earth, and over time that orbit will reduce due to drag in the atmosphere, particularly in low Earth orbit, and eventually over time it will re-enter that atmosphere, like I said previously, and it will burn up and typically be destroyed. And depending on the size of the satellite, you might even see that as like a kind of like meteorite kind of display over Earth, but that could actually be a satellite burning up. Typically, when we're designing satellites, we have to prove that they will deorbit within a certain time frame. So normally we are restricted to 25 years, I believe it is. So we have to prove that the satellite we are sending up will burn up within 25 years at the end of its life. So it's really important to do that and ensure that actually happens. Otherwise, you're going to have all these satellites up there. So
yeah, absolutely. And we've actually just gotten the answer to the previous question about the oldest satellite, and it is Vanguard 1. It was the first satellite to have solar electric power, which is pretty cool. And although communications with the satellite were lost in 1964, it remains the oldest human-made object still in orbit, together with the upper stages of its launch vehicle. So some of the launch vehicle is still up there along with the satellite. So 1964, that is a long time, and obviously not abiding by those rules to deorbit in 20 years.
Yeah, definitely.
Fantastic. Let's see if we've got another question coming through. Are there any satellites around other planets?
Yeah, there are satellites. So as well as around Earth, there's satellites around 5 other planets in our solar system. So around Mercury, Venus, Mars, Jupiter, and Saturn. Mars has many satellites around it, so that's kind of one of the most explored planets in the solar system. I think it's got around 6 satellites in orbit around Mars, doing lots of different observations and communications. So sometimes the satellites around orbit or in orbit around Mars act as communications relays for rovers that are on the surface. So as well as satellites, Mars is also the planet in our solar system that has a number of rovers on the surface going around and doing science, and often they communicate with the relay satellites in orbit.
Fantastic. I think it's so exciting when we get to send things to other planets. Do you think AASC Clyde Space will ever send a satellite to another planet?
That's a great question. We've got, Derek mentioned a few of our subsystems going on board the lunar missions. So that's really exciting to see some of our kit going to the moon. And I'm absolutely sure there'll be people coming up with missions to other planets and more lunar missions in future.
Definitely.
That's exciting. It's just I'm a nerd for space. I absolutely love it. So this is such interesting stuff. Thank you so much. Next up, we have another question from YouTube. This one is from Stephen Hill. Given the cost of the components, is there no way to recover the satellites and reuse them?
That's a great question. So, as Derek said, they often are kind of burned up in the atmosphere when they re-enter Earth. So there's typically not ways to reuse them. Having said that, a lot of people are looking at kind of in-orbit manufacture and being able to replace certain components within spacecraft to extend their lifetime. So often your satellite lifetime will be limited by one particular component, so maybe a battery that degrades over time. So if you could maybe replace that with another battery on orbit, or if you can manufacture certain components on orbit, there's a lot of kind of research, and development, as Derek mentioned, the TRL scale, at the kind of lower end of that, looking at those kinds of concepts. So in future, we may see parts of satellites that are kind of recyclable or at least replaceable on orbit. What you benefit from on CubeSats as well is a lot of reuse in terms of design effort and design of components. So where we can't maybe recycle components on orbit, we do really benefit a lot from standardization of components. So you can literally go on our website and order a battery or a solar panel. So where we benefit from CubeSats and the new space ethos is really around that reuse of design and production, so that we can manufacture it at bigger scale. And again, that reduces the cost and development time as well. So a lot of reuse in the design process.
That's really good to know, especially considering climate change and global warming. To look at longevity and recycling is really good.
Yeah,
absolutely. So I think we've got another question. Is there an upper limit for the amount of stuff that we can send into orbit?
Yeah, I can take this one, Pam. So yeah, I would say definitely there's an upper limit to that stuff, if you like, that we can send in, because obviously you couldn't have an infinite number of satellites orbiting the Earth, because eventually those satellites would potentially collide with each other, which then would have a knock-off effect that might destroy other satellites. So yeah, I think there definitely is that upper limit, but I think a lot of the work just going on just now is in the area of space debris and how you can come up with ways to deal with that problem going forward, like we've mentioned. So I think all of that kind of research and development is ongoing just now, and as the kind of time progresses, dealing with this space junk will become more important as we send up and launch more CubeSats, for example, into space.
Mm-hmm. Mm-hmm. I am interested in, when you are launching and when you apply for a launch, do you have to take into consideration where the satellite's going to go and if it's going to get, in the way of somebody else's satellite?
Yeah, that's right. Yep. So that'll all be part of your considerations when you're applying for launch licenses. And then we're often kind of dictated to where we can go and launch by the launch service providers. So a rocket will be to say a sun-synchronous orbit with a certain altitude and inclination, and we then do the kind of the mission analysis to make sure that orbit is suitable for their mission concept and would meet our mission objectives and our requirements. So often the orbit that you're going to is kind of driven by the launch vehicle, as I say, because we often piggyback on a larger satellite launch.
Yeah, definitely. But there is a potential as well in the future to change your orbit as well once you're up there. So you can use a propulsion system, for example, on a CubeSat, and that could change it, or you could, depending on the rocket and the deployer, that might have its own propulsion system in it as well. So there's a lot of exciting areas of development, I think, going on just now.
Wow, amazing. We've got another question coming up from one of the schools that is watching today, and that's from Paisley Grammar School. And this is more of a career question. What would it take to join the space program?
Yeah, good questions. As I mentioned earlier, we're now seeing many more people getting involved with the space industry that we didn't see even kind of 5-10 years ago. So it is still a relatively new industry. So there's so many opportunities to get involved, you know, from a kind of personal perspective. Studying kind of science and maths related subjects is a good way in. Having said that, the careers are so diverse. So you could go and study medicine and be involved in the space industry, or marketing and communications, or law even. So space law is a really kind of emerging part of the industry. So there's loads of opportunities to get involved. It's an area, particularly in the UK, that's only going to continue to grow. So Scotland and the UK have set really ambitious growth targets for space. So I would say if you're interested in being involved, pursue those types of subjects, look at possible careers. And I would say as long as you're interested and passionate about it, you know, our kind of tagline at AAC Clyde Space is awesome. And genuinely that is how, you know, everybody feels who works there. We all just are really interested in space and really passionate about it. So I would say maintain that interest, and there's plenty of career opportunities in future.
That is very good to know. We have time for just one more question, and that is, what is the next big thing for the satellite industry?
Okay, I can take this one, Pam. So I think one of the next big things is going to be the design and launch of constellations of small satellites. And we're starting to see that happen already just now. And I think as time grows, that's going to get bigger and bigger and bigger. And it's going to be the actual using what those satellites can do to better life on Earth. So actually using that data. And that's something that at Clyde Space, at AAC Clyde Space, we're going all the way from the design and manufacture to actually supporting the launch, and then the operating and getting the data down to Earth to actually use that data in a useful way. So I think that's going to be a big driver for the future. Yeah.
Wow, such amazing questions and answers we've had today. Thank you so much, both of you, Pam and Derek, for joining us today. I don't know about everybody else watching, but I'm super excited about the future of space in Scotland, but also the world. We do have a few more programs coming up today, so keep an eye on our website and make sure you tune in for the rest of them. So thank you again, and we'll see you for the next installment of Get Curious at Glasgow Science Centre.
Thanks.
Thank you.